Well, hi, and welcome to my shop, and thanks for joining me here today for a little more work on this radio. Yesterday I was pretty excited because I got through everything and got the radio to work maybe 80%, maybe 90%, and I felt pretty good about it till the last observation, which was the tuning meter isn't in the center when the station is peaked up. So that suggests more alignment efforts required. So since yesterday, or first thing this morning, I came in, I changed out this little capacitor here, which is sitting right here, which I've left in up until this point. I also removed and checked this one. This one's actually in good operating order, so I've just left it back in. But the one here that is driving me nuts is this little capacitor here. And you see that it's disconnected. This is how I found the radio when I got it. I discovered this capacitor was not connected. I thought it probably just popped off somehow. How exactly something like that pops off, I don't know. So I've been trying to and I've left it. I had it connected for a while, then I had it disconnected again, and I finished the alignment with this capacitor disconnected. What is the implications of that? I'm not sure. Once again, I'm going to try to figure out what this capacitor is and where it should be connected, why it's there, what it does, and what the consequences would be of having it disconnected this way. You might see some other parts hanging out here. This is a little circuit for detecting the output of the IF stage. This is actually disconnected, just the ground is still soldered, so it's hanging here. I'm anticipating having to reinstall it. The actual signal lead is here. It's open. And you might notice this resistor sticking out here. Also, this is another resistor for test purposes, going to the same test point 1, same as this guy, if I wish to not utilize the detector circuit. And you might see this hanging out. This is test point number 2. Just hanging there in case I want to do something with it. And that's about the story. Now there's still lots of this type of somewhat unreliable capacitor all through the amplifier. I have not changed any of those. My thinking here was get the radio receiving before fiddling around with the amplifier. And the amplifier seems to work fine. At this point I have no reason to think there's a problem with it. So the challenge here is to figure out what this is doing. Now I know exactly which one this is and where it is on the schematic, so we're going to go take a look at it, and I'm going to try to talk my way through understanding it. Let's get the schematic up there. Okay, let me zoom out here and switch on my noisy microphone. You just check it here. Those are the other microphones. They're all picking up noise. Isn't that annoying? This one in particular, though. Oh well. Okay, I'm going to continue now. We'll just have to listen to that noise a little bit. The capacitor is right here. This is the one that's disconnected and hanging open. It's a small 4.7 picofarad capacitor. It's connected here in this little circuit, which I'm going to try to explain momentarily. And the other goes up, over into the first FM transistor. I think we can call it that. That might not be correct. Could have both AM and FM going through it. Not clear to me, but that's not to worry about. This is definitely the FM signal path. You can see 10.7 written there. This guy's involved with it. It goes right into the center tap, or looks like an off-center tap here. So this capacitor is connected right into the start of the FM IF. And I don't have it connected. What could it possibly be doing? Well, if we were to trace these wires back, I have to trace them a long ways. is we get to this switch, the AM FM switch. And if you look at it long enough, you'll realize, I realized anyway, it's switching 12 volts. So out of here is coming 12 volts up through here, through a little coil. It says right there, plus FM. There's some another one over here, plus FM. I don't know what to say about that, not to worry about it. And here's a plus AM. That's going to the other side of the switch. So if you slide the switch to AM, this guy gets 12 volts, this guy loses his 12. That would quiet all this down. You're just basically switching from one front end to another. An AM front end and an FM front end. There isn't much to the AM front end. Okay. We have a diode here. Positive voltage. This is going to have a forward voltage drop that's fairly fixed. 0.7 volts, I think. I'm not sure what kind this is. 0.7 or 0.3, something like that. Kind of a fixed voltage here. This would be a voltage divider dividing the remainder. So you got 12 minus roughly 1, 11. You're dividing it with 50,000 here and 7,000 here. So the bulk of this voltage is dropping here. You're left with some amount. Where's it going? You got a big capacitor here. Getting rid of any nonsense that might be there. Oh, look at that. Oh my gosh, this answers one of my questions right here. AGC plus 1.4 volts for 0 input. Okay. Okay, this whole picture could be different here. What could be happening is some amount of signal is taken out of here and goes through the capacitor and gets detected, if you like, or rectified by the diode, causing this voltage to go up a bit, causing this to go up a bit, up or down, I don't know which way, one way or the other, causes a change in the bias, in the base voltage here, in the way this transistor is biased. What is this transistor? This is the number one transistor in the whole chain, coming right from the antenna. So this would be the AGC system I am seeing here. And I've got this disconnected. Okay, for the first time this is starting to make some sense to me as to what could be going on. Now, the story I'm telling could be wrong. You could easily know this stuff much better than me. Maybe I've come up with the wrong story. But the story I've come up with says you got to have this thing connected or there's no AGC operating out here, unless somehow it's brought in other ways. There could be other. There don't seem to be any other way in which it would be done. Well, this guy, that means this one has to be connected. Could be why when I used my test signal generator, I discovered the lowest FM output of the test signal generator was at the top of what this receiver can handle. It doesn't make logical sense that they would build a test instrument that does that. It has a variable control in the front to turn the output up and down. If I turn it up at all, it's too much. That says AGC not here. Would this be a really important thing to have connected during alignment? I'm not sure of that. Obviously it would help prevent overdriving of the radio. Hooking a capacitor like this right onto here, perhaps it shifts the resonance of this a little bit and you would compensate by tuning it out. But I didn't have it connected. Uh-oh. Why was it disconnected when I first came across the radio? Maybe it just popped off. I don't know. Maybe it was taken off for testing purposes and not returned at some point by somebody. We have this AGC plus 1.4 volts for 0 input. We should really look at that. And then apply an input and see what happens to this voltage. And then fool with the capacitor and see then what happens with this voltage. So this I found this once before where to connect it, and I made the connection and then I removed it a little bit later, thinking, well, I better just leave things the way they were, not, you know, somebody conceivably did this on purpose. But now that I look at it, I can't imagine what the purpose would be, other than to disable AGC for some testing purpose. As if this capacitor were defective in some way. Is it possible the AGC is too much? And by disconnecting it, the receiver went from being quiet to being working, and somebody left it like that. I don't know. I gotta tell myself these stories to try to determine a sensible thing. I think the most sensible thing is to do what I said. Measure this voltage, make and break this connection, see what happens, put in a signal, put in a strong signal, weak signal, all that stuff. Find out what's going on here. It could even be that there's a defect in him, like me. This guy's defective, and somehow disconnecting the capacitor compensated for problems here and brought the receiver back to life. Maybe the person who did it didn't know what they were doing. Kind of like me. Yeah. Okay. That's my plan. I'll set up for measuring this voltage and reconnecting this thing on and off if I can do it. Well, it's quite clear to me that the small noise you can hear right now kind of would sound like something coming out of a receiver is actually coming out of my audio system, and it's computer interference with my audio system that for some reason I just can't drum out at the moment. So hopefully it's low enough that it won't interfere with what we're really trying to listen to. So I'm going to turn the volume up on the radio. It's operating now. We're going to make and break this connection and see if it interferes. This is the connection that's feeding the AGC voltage over to my meter here. So let me turn up the volume. I think there's music playing. It's probably copyrighted, so we'll have to do this quick. No effect. Okay, no effect. I could have sworn when I turned the volume up, the noise disappeared. Did that really happen? I think it's just a psychological thing. Once the sound gets above the noise level a certain amount, you cannot hear the noise anymore. So that's a beautiful thing. It's a beautiful thing. That's why you can listen to old records with all the scratches and pops. Okay, seemed to work. Here's a meter reading. Meter reading over here. We're on a 5-volt scale. So the reading is about 1.4 volts, 1.5 volts, and that's right what it said it should be. Oh, that's with zero signal. Zero signal. So the question is now, as I tune things in and out, does this go up and down? That would be the question. Let's see what happens. I do have the signal generator running, so we can really use a controlled signal to do this too. But for now, I'll just tune around a little bit through some stations. We'll just see what happens here. Hopefully, my arm's going to go right in front of the meter, isn't it? I have to do that. Okay, here we go. I don't see any movement. There's the signal generator. We're going to stay at the signal generator. Okay. Just based on listening to it, that sounds like it's tuned pretty good. I'm going to up and down the output, the RF strength of the signal generator, and we'll see what just happened there. Oh. I don't actually have the signal generator connected here. It's just loosely coupled. Oh, let's couple it right in there. I'm going to take off the antenna here. measurement in the meter. That's got to be a huge signal variation there. Now I'm going to turn it up and down right on the control here. Doesn't sound like it's going up and down, but it surely is. No change on here. No AGC. No AGC without the AGC. So why would you turn that off? I think you would turn it off during some kind of testing. You would interrupt it during some kind of testing process and then reconnect it afterwards. And it never got reconnected. That's my guess. So I'm going to study now very carefully on where to connect that capacitor. So the capacitor in question connects to this transistor to the collector on it. And how do I know that's the collector? Well, the symbol reveals it, but up here, they put this here. It's kind of interesting how they've shown transistors. I don't know why they've done this, but they show the emitter and the base as being kind of within the body, if you like, of the transistor symbol anyway, but they show the collector protruding way out here. Maybe that's just a way to make this terminal really stand out on the schematic. So when you glance at the schematic, you can immediately pick up the collectors for all these transistors. I'm like my only guess what they're doing here. So this is connected to a banana-shaped trace here. If you look very closely, this connection is actually not on a trace. So I'm going to actually show it clear. So you find a banana-shaped trace with two connections in it, not three, right next to this big round thing. And then along here is obviously the grounded trace on the board. So you come along the board and look for the banana just around the ground thing, and this connection needs to be made either to this terminal or you can make it to this terminal too. Either one. And then this matches the schematic, because I remember this was connected right into here. Made me wonder about that capacitor. Okay, now let's look at the board and see if we can spot this. Also notice the transistor is right beside this can, which is the third can in a row. So it should be easy to spot, or I've already found it. So let's go look at it. So what I've done is I've positioned a bright light behind the board and turned everything else off in the shop. So we could look and see where this part is. Now it might be a little hard to do on the camera from such a distance, but I'm just going to go with it here. Whoops, didn't work out, did it? Spent quite a bit of time getting that light to sit there. I'm going to hold it. So I don't know if you can see the terminal down here. This clip is in the way. Let's get it out. So there's a big ground lug in there. Can you see that big? Kind of hard to realize what you're looking at. It's reflecting a bright beam of light right down at the bottom of the board there. That's the ground lug. And we're looking for the banana around it. And I can see the banana here. See two terminals. There's a third soldered, unsoldered wire coming out over here. So it all matches. So this is definitely where that capacitor goes on either one of these two wires. I'm pretty sure I figured this out correctly once before. So I'm going to solder it on there, and then we're going to repeat those tests and see if all of a sudden AGC isn't working, and that's a huge change in radio. Okay, resistor's back in place. Capacitor's back in place. Ready just to repeat the test. Voltmeter connected. Voltmeter visible on the camera. Yep. Any reason to not turn the set on? Nope. Okay, here we go. Let's come right up to 1.4, the same place as before. Oh. Right. Okay, I'll tune the radio a bit. Let's see what goes on. Nothing. 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 Okay, we'll change the output of the signal generator. I gotta move the camera over here. Oh, there is some difference now. Just a tiny amount though. I certainly hear a difference in the sound. I hear it in the headphones. Just turn it up a little bit. Sounds like an overload to me. So what is the idea here? The idea must be with more signal to drive this downwards. It certainly isn't going down much. Maybe the capacitor is not doing its job. Resistor's out of whack. Diode's bad. Or my AGC test I'm doing right now is bogus. There's something wrong with the way I'm doing this. I can't imagine what's wrong with how I'm doing this. How else could you do it? I have the opportunity to vary the input here. Let's take the signal. Look, we really weaken it. It didn't sound like it weakened it. There's probably a frequency shift going on, maybe in my signal generator. Tune the radio here a bit. Okay, it's real happy right there. Seems happy here. I think it's a shift in my signal generator. I'm sure you're supposed to design these things so that exact problem doesn't happen. Oh boy. Oh, what to do about this now? Maybe somebody disconnected that capacitor to test it. Maybe that's what I need to do next. I should have tested it before I connected it. Duh. Okay, doing things a little out of order, but that's okay. I'm done. 4.7 picofarads, eh? Let's see what you say on this. No unknown or damaged part. What? Well, I'll be okay. What happens if we just run this test with nothing hooked up to it? Okay, a capacitor with no capacity. Okay, that's good. Okay. I'll find another one. 4.7 picofarads. Okay, so I put in this type of capacitor here. I'm sure it's just fine. Put a 5 in. It was going for 4.7. Can't see the difference there. We'll hook up our test. Let's not hook it up right away. Let's test and make sure that it's not interfering with the radio. What a mess my bench has turned into. There we go. Okay, headphones. Put on my headphones all the time. There we are. Okay, that gravelly noise is coming from the radio. Okay. What do we got on the meter? Oh my gosh, look. Oh, the meter's not connected. Does it make a difference? Don't hear a thing. 1.4. Okay, and we're going to vary the input up and down and see what happens here. Look at that. So I don't think a range is given. Notice the sound in the sound you're hearing isn't changing, even though I'm cranking up the output. Okay, that's a great improvement. I don't know what it means about all the work I've done to this point. It may have nulled it all out. I'm going to put the antenna back on. We're going to listen to this radio before I do anything more. Okay, so what's all that noise? Coming from the radio, not from any microphones. Okay, of course you're listening through these outputs, not through the speakers. And don't hear really anything. Oh, tune the radio, see what we find.
Crying out.
So what we want to keep an eye on is this meter. We're tuning things here. Just watching this guy to move. Allowing that. Need a strong station. AFC is off. Come on, any one of you stations, move this meter.
Fresh 93.1.
That took place when they were.
Well, no signals are strong enough to do it.
Lynched, and that's what civil rights activists said aroused them to struggle. What happened to Emmett Till, it was symbolic of something, and for these young people,
Okay,
it was
tuning
Trayvon Martin.
meter.
And so that's what I heard from a lot of folks. A lot of times it was about what was happening in the broader world. A lot of times it was
Not in the
very
center.
situational for what they were dealing with at that particular moment. But what Colin Kaepernick provided for them was a method. It was a language. It was a way by which they could express their dissent, whether they were in a big city or a small town.
Looks to me
that
like
you
the
read
center
about your
is
book,
about
and let's
here,
start with a guy named Rodney Axon
off to the
Jr.
right.
Tell us about him.
Well, Rodney was a student at Ohio's
This
Brunswick
is a
High School,
mono
and
station.
through
so
my
let's
research,
find
I
a
realized
stereo
that he was the
station. I'm
first
gonna move the
athlete
antenna here.
following Kaepernick to take a knee during the anthem. I mean, he saw what Colin Kaepernick did, and immediately, at a very young age, you know, it's amazing as youth that he saw this was going to be something that could catch fire, and he wanted to be a part of it.
Okay, so I think it's really important to remember when you're talking about Rodney
I
Axon
think that's
Jr.,
a
we're
better
talking about
position.
a 17-year-old kid. His team, so I just say that because if whether you
Watching
deem
the
this to
stereo
be
light.
a brave thing to do or disrespectful, my point is that we're talking about a very young person making that decision for themselves. And
here.
his team is getting ready to play against a team from a black high school.
Most every other station is stereo. Weak. Oh. Holy smokes it. You know, it might have been the noise that made that light flash. Stronger station. Maybe a stronger station.
Get it for free now in your app store. Canadian radio plays.
At Hitch City, they understand you use your vehicle to do more than just drive to work.
I'm gonna wave
For
the
over
antenna
40
around a
years,
little bit
they've
here.
been helping customers get more out of their vehicles. Hitches to ski racks, running boards to tonneau covers. It's in stock and ready to install. Visit hitchcity.com.
Change the way you motorize.
In Barrie, Scarborough and Mississauga. Hitch City, more than just hitches.
To all who've stopped in to see the fantastic creatures, Tropical Gem says tanks. Big tanks, small tanks, tanks for fishing.
Well, I think this proves the case. We're still not getting enough signal through the radio. Because not one station is turning on. Okay, that's the end for today. I'm not really sure what I gained. Basically, solved the mystery of the capacitor. I put something in there that seems to be doing the job now, but the receiver is still substandard. It's still not good enough to trigger the stereo. It's way off from that. So there are other possibilities here. The possibilities are weak components still in the receiver somewhere. I would hope that's not the case, but but alignment is the main thing that I would want to try to touch up on this. Although I think it's close enough that the testing I've done is kind of suggesting me I can't align my way into perfect performance. But you know, I could easily be wrong, and the only way to know is to actually go through the process. So I'm pretty good at it now. Maybe I mean, it'd be much quicker to go through it than before. So, but that's it for today. What can I say? Have a great day. I'll see you tomorrow in my shop again. Bye.